Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from Group C. We present to you about the wastewater treatment technology of agrochemical industry. Okay, as for introduction, industrial wastewater is a major challenge in processing industries as organic and inorganic particles in varying concentration are common in industrial effluent. Okay, in these studies, the wastewater treatment technology will be focused on the agrochemical industry application. So, the agrochemical industry is a part of chemical industry's life science division, and it deals with the manufacturing and distribution of pesticides and fertilizers to promote the agricultural yields. Generally, pesticides are employed as a part of an integrated crop and as a pest management plan to boost productivity and minimize 30 to 40% of losses caused by the pest during production, processing and also storage. However, the use of pesticides can damage and affect the human and environment health. So, pesticides have been demonstrated to be hazardous to in the individual and environment in several studies. Consequently, the wastewater produced from the agrochemical manufacturing industry is observed to be the most important portion of contamination, as the wastewater are come from the agricultural area. So, in this study, the wastewater treatment of the agrochemical technology will be focused on the reverse osmosis, nanofiltration and also advanced oxidation process.
I want to explain to you all about the technology. First, about the reverse osmosis technology. So this is the one of the most important and energy efficient technologies. In RO, the monovalent ions like Na plus and Cl negative are separated from water through a semi-permeable membrane. Due to higher external pressure than the osmotic pressure, the water molecules are forced to flow in the opposite direction than that of the opposite phenomenon. Reverse osmosis works on high pressure, and the pressure vary from 20 to 70 bar, and the permit flow ratio ranges from 10 to 100 liter per H per m square. For the mechanism of reverse osmosis is the aromatic polyamide present in the reverse osmotic membrane is responsible for its high retention efficiency. Along with this, size exclusion, electrostatic repulsion, and hydrophobic or supermolecule interactions are also responsible. Hybrid techniques, including reverse osmosis and carbon filters equipped with drinking water treatment plants, are also found to be effective for removing several ECs or emerging contaminants. Even compounds having smaller molecule weights like nitrosodium methylamine, dioxane, and 2-methyl-sorbonyl have a greater removal rate via carbon filters. The principal mechanism for removal of this compound was steric hydrants. Molecular dynamic simulations also revealed that the high absorption of phenolic compounds with RO membranes. So, for the second technology is nanofiltration. The removal of emerging contaminants on NF was around 90%. The new form of EC is known as perfluorooctane sulfonates. PFOS is commonly used in surfactants, fire retardants, lubricants, coating material, and metal plating solutions. PFOS is a very minimum quantity, is also considered very toxic in the water. Surface morphology and pore size played an important role in surface adsorption. The pH of the medium played another crucial role in the removal of ECs. At low pressure, the desired retention of ECs was observed because of steric hydrants and dynamic interaction between membrane surface and solutes. So for the mechanism of nanofiltration, it was concluded that it is because of permeate flux and physiochemical properties of ECs. Removal of cyclophosphamide was demonstrated with an F-hollow fiber membrane having charged surface. The membrane was designed using hyperbranch polyethylene amine as cross linkers to the polyamide backbone. The flux of the membrane was very high because of the sponge-like structure porous membrane. Membrane pore size decreased immensely after cross-linking with PEG. This made the surface of the membrane hydrophobic with a positive charge.
Next technologies is advanced this pesticide use the advanced oxidation processes, AOPS. So these technologies with significant importance in environmental restoration applications. The process involving the generation of highly reactive oxidizing species able to attack and degrade organic substances, and these technologies also can combine with ozone catalyst or ultraviolet irradiations to offer and powerful treatments of wastewater. We also considering that these technologies has a high efficiency of physical and chemical processes. It's due to their thermodynamic viability and capable of producing deep changes in the chemical structure of the contaminants. Okay, the advantage of these technologies is its faster reaction speed and shortened retention time. And then this technology is able to oxidize organic pollutants mainly by hydrogen abstractions, like shown at the equations, or by electrophilic addition to double bond to generate organic free radical, which is R point. This radical can react with oxygen molecules, forming pre-oxy radicals and initiate oxidative degradation change reaction that may lead to the complete mineralizations of the organic. Free radical in AOPS produced by photochemical and non-photochemical processes. The table at the next slide is the list some of the most frequently reported AOPS for application in the water restoration. So among the different approach for pollutants removal from water, some of them are recognized as mainly efficient for pesticide degradations, oxygenations and ozone related process, heterogeneous photocatalysis, homogeneous photocatalysis Fenton and Fenton-like process, and electrochemical oxidations are considered the most efficient for pesticide degradations in water.
In conclusion, it is sufficient to treat the wastewater from the agrochemical manufacturing industry. It's not only important to the environment as it is important to human being in order to avoid negative impacts such as groundwater pollution, soil fertility and also immunotoxicity in humans. Okay, in wastewater treatment, in order to remove pollutant from huge quantities of water, wastewater treatment plant use biological, chemical and also physical principle under the specified circumstance. Okay, wastewater treatment may be done perfectly will reduce the total lifespan cost, less energy and fewer equipment if all of these modern technologies are used. Okay, that's all from me. Thank you.